This video is going to talk about acceleration. So in the book you've read that acceleration can mean one of three things. It can mean that you are speeding up, slowing down, or changing direction. And the easiest way to think about that is in a car, because when we push the accelerator, we speed up. But if we push the brakes, we're slowing down, which is also considered acceleration. Sometimes we call it deceleration. Another type of motion that can cause acceleration is changing direction. So our speed could actually be the same, but if we turn in our car, if we turn left or turn right, that can be considered acceleration just because we're changing direction. So it doesn't necessarily have to just be speeding up. It can be speeding up, slowing down, or changing direction. And the scientific definition of acceleration is the motion that describes a rate at which velocity changes. And notice that word velocity because velocity incorporates speed and direction. So let's talk about how you actually calculate acceleration. Here is the formula for acceleration. Acceleration equals final speed minus initial speed over time. So it is a rate because we're looking at the change. And then down here, it's talking about your units. The units can be a little bit confusing with acceleration. Speed, which we have at the top of our formula here, is measured in generally meters per second. Sorry about the bell. And time, on the bottom part of our acceleration, is measured in seconds. So our label is actually meters per second, or we can just say meters per second squared. And if you were using miles per hour or miles per minute, it would be the same thing, miles per hour squared or miles per hour per hour. So let's look at an example here. This example is in your textbook on page 98, and there's a diagram at the bottom. So if we're looking at this plane here, and we wanted to find the acceleration of the airplane, let's just say through the first 3 minutes of it taking off, or excuse me, 3 seconds of it taking off. So you can see here that it starts with 0 meters per second because it's starting at a resting position. And by the time it gets to 3 seconds, it is traveling at 24 meters per second. So if we use our formula, and our formula says final speed minus initial speed. So our final speed at 3 seconds is 24 meters per second. And we are subtracting our initial speed. Since initially the plane is at rest, our initial speed is 0 meters per second. And the time on the bottom is the time it takes to go from 0 meters per second to 24 meters per second. So the time it's on here on the timer on this picture, it is taking 3 seconds to do that. So if we take 24 minus 0 is 24 meters per second over 3 seconds. When we divide, we get 8 meters per second, or we would write that as 8 meters per second squared. So this would be our acceleration of the airplane between 0 seconds and 3 seconds. Let's look at one more example. What if we want to know the acceleration of the airplane as it is landing? So this would be an example of a deceleration or slowing down. So let's just say that our final speed is 0 meters per second because we're stopping. We're coming to a stop. So our final speed is 0 meters per second. And before we begin to stop, let's say that the plane is traveling at 40 meters per second. It takes this plane 10 seconds to slow down from 40 meters per second to 0 meters per second. So if we subtract 0 minus 40, we actually have a negative 40 meters per second. Excuse my writing here. 40 meters per second. Negative because we're slowing down. And you can see that here, 0 minus 40 is negative 40. And then we said the time it takes to do that is 10 seconds. So negative 40 divided by 10 is negative 4 meters per second squared. This negative is indicating a slowing down of the vehicle, of the airplane. So that is considered a deceleration. I hope acceleration makes a little bit more sense to you now. You're also going to have a brain pop to watch, and there are examples in your textbook.